In this collection of videos, we are going to be talking a little bit about programming languages in general, and we'll have an introduction to data types in the R programming language. Now, when you're learning any language, be it a programming language or not, there are sets of rules that one must follow in order to be understood within that language. These rules are called the syntax of the language. So in English, this would be things like rules about where we place capital letters, punctuation, apostrophes, where an adjective goes when describing a noun, etc. Those are syntax rules of the English language. Programming languages are going to have a syntax too. When one does not follow the rules of the syntax of a language, we say that they are making a syntax error. There is, however, another type of error that we can make when speaking within a language, which is a semantics error. This is an error in logic or an error in meaning in what you're communicating. I've given an example here with a classic tale of Amelia Bedelia. Now, Amelia Bedelia is a character in a book who often misunderstands people's intentions, and that kind of misunderstanding is a semantics error, as we'll see here. When I look at the sentence, Amelia Bedelia was told to plant bulbs. When she was done, they lit up the whole room. Our eye is immediately drawn to the syntax errors in that quotation. Things like capitalizing an E when it ought not be capitalized, forgetting to capitalize the B in the last name Bedelia, placing an apostrophe where it doesn't belong. All of those things are syntax errors. However, the mistake that Amelia Bedelia makes by planting light bulbs into a set of pots instead of plant bulbs is a semantics error. In describing that part of what Amelia Bedelia has done, we have not made any grammatical errors in this sentence. However, a different kind of mistake was had, and that was a mistake in understanding. That is our semantic error. We are about to undertake learning a brand new programming language, and so the easiest errors to make in the beginning and the easiest errors to catch truly will be the syntax errors that we make. And our IDE is set up to actually help us attempt to find these syntax errors. So while frustrating, the error messages we get while coding are helpful. However, semantic errors are the much more difficult type of error, and our IDE will not generally be able to help us there. This is a very human aspect of the computer programming practice that needs to remain with humans, the ability to find errors in understanding in code, those semantic errors. As a novice to a brand new language and possibly a brand new way of thinking, you are going to make a lot of mistakes. This is actually a very good thing. Very few things are learned when everything goes correctly. All of the learning happens when things do not go correctly. So please be prepared to make a lot of errors and do your best to have a frame of mind that these errors are natural, they happen to everyone, and this is a good part of the process. An added challenge when you're learning a new programming language as opposed to a new foreign language is that this language, the language of R, truly only contains 54 words. So not only do you need to learn to express everything you want done in a different language, that language only gives you 54 words in which to express yourself. This is an added and new challenge that you would not experience if you were learning to speak, for example, French. Please understand that children and people in general take years to learn languages properly. Expect that even after an entire semester of practicing a new programming language, you still may not feel as though you're an expert in that language. The last thing I'll say here about mistakes is that no matter how much you practice and no matter how fluent you get in a programming language, there are always new and beautiful mistakes you can make, and that's okay. The mistakes never stop, the learning never stops, and that's what makes it great. In terms of technical information for today, the thing I'd like to discuss is a brief introduction to data types. Inside of a computer program, we are going to need to store a lot of values, and not all things that we need to store are the same. The way that we distinguish between the different types of things that we need to store and work with is through data types. Technically, a data type is a set of permissible values for that thing and operations that are allowable to be performed on those things. There are a few formal definitions from computer programming that we can learn here that can help us better understand what's going on behind the scenes with a computer. When learning a new programming language, that language might be dynamically typed and it might be statically typed. R is an example of a dynamically typed programming language. And what this means is that it is not the programmer's job to tell the computer the data type of the object. The language is going to determine the type of the object for us. This is nice on our end. In a static language, the computer programmer needs to know ahead of time what the data type of an object is and tell the computer that. This is not the case in R. We do not tell the computer what the type of an object is. The computer will figure that out for us. While it might seem as though this is the natural way of things and all programming languages should be dynamically typed, this will come back to us later. There will be times where the data type of an object is important to us and we don't know what it is because the computer decided for us. There's a quick and simple fix to this in R. Inside of R, there's a function called class that we can use, and we can pass as an argument to the class function the variable that we wish to know the type of, and the class function will tell us. So while we don't determine what the data type of the object is, we can ask the computer to tell us what the type of the variable is, which is very helpful. There's also the notion of strong versus weakly typed programming languages, and R is an example of a weakly typed programming language. And what strongly and weakly typed has to do with is how we are allowed to combine different types of objects. So if we have two different objects and the computer internally is thinking of those objects as being of different data types, to what extent are we allowed to combine them? Here is an analogy. We're just going to use apples as one type of thing and oranges as one type of thing. In a strongly typed language, it's perfectly acceptable to take multiple apples and combine them. Here, you could take multiple apples and combine them to get applesauce. It's perfectly allowable to take oranges and combine them. Maybe we want to make some orange juice. In a strongly typed language, however, taking these two very different things and trying to combine them into something like fruit salad is not allowed, and our computer will generate an error. In a weakly typed language, which remember, R is weakly typed, the language will attempt to take two different types of things and resolve their differences in order to combine them in a meaningful way. So in a weakly typed language, it is still perfectly acceptable to combine multiple apples into applesauce, multiple oranges into orange juice, but that language will work hard to figure out a way to take apples and oranges, to combine them, so that hopefully, at least theoretically, we can get fruit salad. Again, this may seem like the benefit, but there is a potential danger lurking in the background, which is we are not in charge of the conversion that the computer will do and what it might do to the apples and the oranges in the background in order to combine them. So while it might give us the fruit salad that we desire, it might also give us something that we don't expect, like taking orange juice and pouring it on apples, or chopping them all up and intermixing them in a very strange way and trying to merge them back together. So it can sometimes be very difficult to understand the way in which the computer will resolve the differences between the two things and what the outcome might look like.